Maya skies. Ancient Maya and the mathematics of Venus. If you're here to fall asleep, you're in the right place. We're standing in ancient Maya territory. 1,000 years ago. Atop a pyramid in Chichen Itza or Palenque. Watching Venus with mathematical precision that would not be matched by Europeans for centuries. The Maya looked at the sky and calculated. They predicted Venus cycles, accurate to hours over centuries. They created calendars more precise than anything else in the world. Lower your volume. Close your eyes. Let the mathematical stars carry you to sleep. Let's begin with your breath. The breath of ancient nights when mathematics and astronomy were one sacred art. Hold. Suspended like Venus at its brightest point in the evening sky. And out. Releasing into the cycles the Maya calculated with perfect accuracy. One more time. In. Drawing from 1,000 years ago when Maya astronomers tracked planets with precision that seems impossible without telescopes. Hold. The stillness of a jungle night between Venus rising and out. Surrendering to the rhythm of calendars within calendars, cycles within cycles, time itself. As mathematics. Good. Let your breathing return to its natural rhythm now. Like the sacred calendars turning. 260-day Tzolkin. 365-day Haab. 584-day Venus cycle. All meshing like gears in a cosmic clock the Maya understood perfectly. Tonight we stand with Maya astronomers on pyramid summits, recording Venus positions with obsidian precision, calculating dates thousands of years in the future, creating calendars so accurate they rival our own. You don't need to stay awake. Just listen until sleep finds you. Until you drift like a calculation through the long count, marking time in the Maya cosmos. Let's begin. Part 1, the Maya Sky. Mesoamerica, 250 to 900 CE. You are standing atop El Caracol, the observatory at Chichen Itza. A circular stone building unlike other Maya structures. It has windows aligned to Venus. The year is approximately 800 CE. Classic Maya civilization at its peak. Below you, the jungle stretches endlessly. Stone cities hidden in green. Temples. Palaces. Ball courts. But you are not here for the earth. You are here for the sky. Above you, the tropical night. So dark that the Milky Way casts shadows. The Maya called the Milky Way the World Tree, or the Road to Xibalba, the underworld. Venus shines brilliantly in the west. The planets are visible. The stars of the zodiac, though the Maya had their own zodiac, different from European constellations. This is what Maya astronomers saw every clear night. And they recorded what they saw with remarkable precision. Not just casual observation but careful measurement, detailed calculations, mathematical models that predicted celestial events years in advance. The Maya were obsessed with time. Not the way we are, watching clocks to catch trains, but philosophically, religiously, mathematically obsessed with cycles, periods, patterns, the intricate mesh of different time systems. They had multiple calendars running simultaneously. The Tzolkin, a 260-day sacred calendar. The Haab, a 365-day solar calendar. The calendar round. The combination of Tzolkin and Haab that repeats every 52 years. The long count, a count of days from a mythical creation date that tracked dates over thousands of years. And specialized calendars for Venus, Mars, the Moon. Why so many calendars? Because different cycles matter for different purposes. The Tzolkin governed rituals, divination, sacred ceremonies. The Haab governed agriculture, seasons, civil events. The long count recorded historical dates. The Venus calendar predicted when the morning star would appear. All these calendars had to mesh perfectly, like gears in a watch. And the Maya calculated how they meshed with mathematical precision that required sophisticated number systems and astronomical knowledge. The Maya invented zero, independently of the Indians who also invented it. Zero as a placeholder, as a concept, as a number. This allowed positional notation, the idea that the position of a digit matters. In Maya numbers, a dot in the ones place means 1. A dot in the 20s place means 20. Same symbol, different value depending on position. With zero and positional notation, the Maya could write very large numbers. Millions. Billions. Numbers that stretched far into the past and future. Their long count dates go back over 5,000 years before the classic period and extend thousands of years into the future. They thought in deep time. And they used these mathematical tools for astronomy. Particularly for Venus. Venus was sacred to the Maya. They called it Noek, the great star. It was associated with war, with the god Kukulkan, the feathered serpent, with cycles of death and rebirth. Venus was dangerous. Venus was powerful. Venus needed to be tracked precisely. The Maya knew Venus has a cycle. It appears as evening star, visible after sunset, disappears, reappears as morning star, visible before sunrise. Disappears again, returns as evening star. The complete cycle, from one evening star appearance to the next, takes 584 days. But it's not exactly 584 days. It's 583.92 days. The Maya knew this. How? They watched. For centuries. They recorded when Venus appeared, when it disappeared, in what constellation, at what position. They accumulated data over generations. And from this data, they calculated the cycle with extraordinary accuracy. The Dresden Codex, one of the few surviving Maya books, contains Venus tables. These predict Venus appearances for decades in advance. The math is complex. The cycle of 584 days doesn't mesh evenly with the 365-day year or the 260-day Tzolkin. The Maya calculated how to reconcile all these cycles, when to add correction factors, how to maintain accuracy over centuries. Modern astronomers checking Maya Venus predictions find them accurate too. Within hours over 100-year periods. This is astonishing for naked eye. Observations. No telescopes. No computers. Just patient observation. Mathematical skill, and deep understanding of cycles. Imagine being a Maya astronomer priest. It's a humid night in Palenque. You're on the temple roof. Your task: record Venus. It's currently the morning star, rising before dawn. You've been tracking it for weeks. You know from the tables that in 7 days it will disappear, go into inferior conjunction with the Sun, invisible for about 8 days, then reappear as evening star. You note the exact position of Venus among the stars. You calculate. You check against the Dresden Codex tables. Everything matches predictions made decades ago. The cycles continue as calculated. The mathematics work. In 7 days, Venus will vanish. In 15 days, it will return. And you or your successor will be here to note it, to verify the predictions, to maintain the knowledge, to ensure the calendars stay accurate. Because accurate calendars mean proper timing of rituals. And proper rituals mean the gods are pleased. And pleased gods mean rain, harvest, life. This is not abstract science. This is survival. This is religion. This is power. The astronomer priests who could predict Venus, who could calculate eclipses, who could reconcile multiple calendars, held enormous power in Maya society. They alone understood the cosmic clockwork. Let this ancient sky stay with you as you drift into sleep. The Maya stars. Venus brilliant as a jewel. Calendars meshing like gears. Numbers stretching into deep time. Mathematics and astronomy and religion as one sacred science. Rest now under stars Maya astronomers tracked with obsessive precision. Venus. Following cycles they calculated centuries in advance. Time itself as a mathematical puzzle they solved brilliantly. What exactly did the Maya calculate? What astronomical knowledge did they achieve through their mathematical sophistication? First, they calculated the solar year with remarkable precision. The Haab calendar has 365 days, 18 months of 20 days plus 5 unlucky days at the end. This approximates the solar year. But the actual solar year is 365.2422 days. That extra quarter day accumulates. Every 4 years you gain an extra day. The Julian calendar solved this with leap years. The Maya didn't use leap years. But they knew the Haab drifted against the seasons. They calculated corrections. Some evidence suggests they used a longer cycle where certain years were adjusted to keep the calendar accurate over centuries. Exactly how they did this is debated. The Spanish destroyed most Maya books, but their long-term calendar accuracy suggests sophisticated correction methods. Second, they calculated the Venus cycle with extraordinary accuracy. Venus takes 224.7 days to orbit the Sun. From Earth's perspective, the synodic period, the time from one evening star appearance to the next, is 583.92 days. The Maya calculated this. They knew 5 Venus cycles equal 8 solar years. Actually 5 times 584 is equal to 2,920 days, 8 times 365 is equal to 2,920 days, perfect match. They knew 65 Venus cycles equal 104 Haab years equal 146 Tzolkin cycles, a major calendar convergence. The Dresden Codex Venus tables cover 104 years using 584-day intervals. But they include correction factors. Every so often they adjust by 4 or 8 days to maintain accuracy. Why? Because 583.92 is not exactly 584. Over decades, the error accumulates. The Maya calculated when to correct. Their final accuracy was better than Copernicus achieved 600 years later. Third, they calculated the lunar cycle with precision. The moon's synodic period, from one new moon to the next, is 29.53 days. The Maya tracked this. They knew 405 lunar months equal 11,959 days, a period after which lunar cycles and calendar cycles realign. They used this knowledge for eclipse prediction. The Dresden Codex also contains eclipse tables. Predicting eclipses is complex. You need to know the moon's cycle, the sun's cycle, the points where the moon's orbit crosses the ecliptic, the sun's path. The Maya did not understand the geometry as we do, but they found the patterns. They knew eclipses repeat approximately every 173 days, half an eclipse year. They could predict eclipse possibilities years in advance. Fourth, they calculated planetary positions. Venus was their specialty, but they tracked other planets too. Mars tables exist in some Maya sites. The Dresden Codex may contain Mercury calculations. They knew Jupiter and Saturn, though records of these are sparse. For Mars, they knew a triple conjunction pattern, Mars, Earth, and the Sun. Align in a pattern that repeats every 780 days, the synodic period of Mars. They integrated this into their broader calendar system, finding convergences with Tzolkin, Haab, and other cycles. Fifth, they calculated deep time. The long count is extraordinary. It counts days from a starting point, what we call August 11, 3114 BCE in our calendar. There's some debate about exact correlation. From that mythical creation date, the Maya counted forward in units. 1 kin equals 1 day. 1 yunal equals 20 days. 1 ton equals 360 days, 18 yunals. 1 katun equals 7,200 days, 20 tons. 1 baktan equals 144,000 days, 20 katuns. Long count dates are written as 5 numbers: baktons, katuns, tons, yunals, kins. For example, 9.12.11.5.18 means 9 baktons, 12 katuns, 11 tons, 5 yunals. 18 kins from the creation date, a specific day in Maya history. This system could count millions of days into past and future. The Maya thought in terms of baktan cycles, 144,000-day periods, each about 394 years. They recorded dates from many baktons in the past and calculated dates many baktons in the future. The most famous is the 13 baktan cycle. 13 by 144,000 days equals 1,872,000 days. Equals about 5,125 years. The current cycle in the long count ended on December 21, 2012 in our calendar. This sparked apocalypse predictions, but the Maya saw It has one cycle ending, another beginning, like an odometer rolling over. Significant but not catastrophic. Sixth, they calculated calendar convergences. The Maya loved finding when different cycles aligned. When Venus, Haab, Tzolkin all returned to the same configuration. These convergences were rare. Sometimes centuries apart, but calculable with their mathematics. Finding these convergences required sophisticated calculations. You need to find the least common multiple of different cycle lengths. You need to account for correction factors. You need to think in terms of hundreds of years. The Maya did all this. They calculated centuries-long cycles. They found harmonies between Venus and the solar year, between lunar months and the Tzolkin, between Mars and the calendar round. The cosmos was a vast clock with many gears, and the Maya mapped how those gears meshed. Seventh, they calculated all this without modern tools. No telescopes. No mechanical clocks. No calculators. No computers. Just naked eyes, patient observation, record-keeping, and mathematics. They used their vigesimal, base 20, number system. They used zero and positional notation. They kept meticulous records on bark paper books, codices, and carved them in stone stele. They passed knowledge from teacher to student, generation after generation. And they achieved astronomical precision that rivals what Europeans managed much later with better tools. The Maya Venus tables are as accurate as Copernicus's in the 1500s. The Maya solar year calculation was as good as the medieval European calendar before the Gregorian reforms. All this from jungle cities, from priests atop pyramids, from a civilization that rose, flourished, and declined while Europe was in its dark ages. The Maya were not primitive. They were mathematical astronomers of the highest order. Let this knowledge stay with you as you drift into deepest sleep. Maya. Mathematicians calculating Venus cycles. Calendars meshing perfectly across centuries. Deep time counted in millions of days. The cosmos understood as mathematical patterns that could be predicted, mapped, used. Rest now under stars the Maya calculated with precision that seems impossible. Venus following the path they predicted. Time flowing through calendars they designed. The cosmic clock ticking exactly as they knew it would. The mathematics work. The cycles continue. The patterns persist. All exactly as Maya astronomers calculated 1,000 years ago. Sleep well knowing that humans achieved extraordinary understanding of the cosmos long before modern science. That mathematical precision existed in ancient jungles. That the Maya calculated the heavens brilliantly, accurately, beautifully. And so our night in Maya territory ends. 25 minutes atop a pyramid. Watching stars with Maya astronomers. Learning what they calculated with mathematical precision. We stood under a tropical sky so dark the Milky Way seemed a river of light. Venus brilliant in the evening. Stars of the Maya zodiac overhead. The cosmic clock ticking through cycles within cycles. We learned the Maya didn't just observe, they calculated Venus cycles. Accurate to hours over centuries. Solar year precise to fractions of a day. Multiple calendars meshing perfectly. Eclipse predictions years in advance. All without telescopes or computers, just mathematics and patient observation. Tonight, as you drift into sleep, you rest under the same stars. Venus still follows its 584-day cycle. The Sun still takes 365.2422 days to complete its annual path. The patterns the Maya discovered remain unchanged. What changed was human ability to calculate those patterns, and the Maya mastered that ability brilliantly. You are small. The cosmos is vast and complex. But 1,000 years ago, Maya mathematicians calculated that vastness with precision that would not be equaled for centuries. They proved that human mathematics can unlock cosmic patterns, that the universe follows rules we can discover and predict. Sleep now under stars the Maya counted in the long count. Venus cycling as they calculated. Time flowing through calendars they designed with perfect mathematical harmony. Good night from the Maya world. From Chichen Itza and Palenque and Capan. From astronomer priests atop pyramids. From calculations carved in stone. From mathematics in the sky. The cycles continue. The calendars turn. Venus rises and sets exactly as predicted. All following patterns the Maya calculated when Europe was barely literate. Rest well, calculator. The mathematics endure. The cosmos remembers. You join a tradition of understanding celestial mechanics through patient observation and brilliant calculation. All is cycle. All is mathematical. All is exactly as the Maya calculated. Good night.